Hello, everyone. Welcome to another episode of Hazardous Area Safety. Today we have an international speaker. So we have Chris Cloney from Dust Safety Professionals, and I'll let you introduce yourself and we can start the conversation. So welcome, Chris.
Yeah, thanks, Travis. I'm super excited to talk about combustible dust today, hazardous area. As you mentioned, I run a number of platforms online, one being Dust Safety Professionals. The kind of core and hub of where people come into what we do is dust safety science. We run an instant database there, tracking combustible dust fires and explosions around the world, educating people, increasing awareness, kind of handing them off to what they need. So if they need to connect with a service provider or equipment manufacturer, Dust Safety Professionals is the right place to go for that. They're looking for education and training. We have the Dust Safety Academy. And if they're looking for, other educational material awareness, we have things like the Dust Safety Journal. We run an annual conference, and I forget how many websites we have now, but 5 or 6, depending on the day, all in the sphere of combustible dust, understanding the hazards, why they happen, and then how to stop them at the end of the day.
So here's an interesting topic. How did you get into this space?
Yeah, well, if you think I can't talk about what I do now at a cocktail party or anything, before I got into it was even harder. So I come from defense industry. Right out of university, during university, my co-op position was a research engineer with a consulting firm, and I was doing software development and supporting them on their consulting projects, and that was mostly working with defense industries. So in particular, defense industry in Canada, Defense Research and Development Canada, and other NATO allies, Australia, USA, and others. And I was doing things like designing helmets for troops to avoid traumatic brain injury from an explosion, designing test apparatus, supporting test trials. A lot of other countries would do large-scale explosions. We did a bit out in certain cities, we'll say, in Canada that are remote, and we would support those test trials, try to understand explosions, not industrial scale. This was like, AMPO and improvised explosive devices and that sort of stuff, the kind of really bad stuff. I did that for 3 co-op terms through university, and then signed on full time with that company. I was there until 2016, so that would have been 6 or 7 years I was with them. And in that time, I started studying. At that point, which was 2012, I started studying what was called metal additive explosives. So if you add aluminum and stuff, and was looking at these giant fireballs and how they react and how they change impulse loads on buildings and ships and tanks and all that sort of stuff. And somehow I fell into a research degree, an academic degree in this topic of burning fireballs of metal particles. And I went down the road of what eventually was dust explosions, thinking it was going to be the exact same as all this defense stuff I was doing. And I got into it and looked at it from an industrial standpoint. What's the hazards here? Realized that that's really quite interesting. And I didn't want to do defense research for the rest of my life. I felt like I was making more of an impact in industry application, and then kind of moved into the research side of dust explosions. Realized in our industry, the biggest problem is not really the physics or chemistry of reacting particles and flames and fireballs. It's actually people.
It's the human element.
Educating people. The solutions are out there. I mean, you would know this in your work. The control methodologies are there and available. It's more, do we use them? When do they stop working? If we do put them in the first place, when do they fail? How do they fail? How do they fail safe? All those sort of things. The interaction with the human side was quite interesting to me. So I slowly made my way into industrial dust explosions from this kind of defense research background.
It would have been quite interesting bridging the gap between defense to going into industry, where defense you have like larger concentration of funding, when industry becomes like a ROI discussion.
Well, it's actually quite interesting. You must have a background in things that require government spending or something. Because I've been on a lot of podcasts. I've talked about defense research. I've never had that viewpoint brought up. But it's tremendously pervasive, if I could use that word. So and I'll give you a really specific example, and then maybe I'll let you tell me why you know this. But the specific example is just that. So it's well funded. Um, it's also like now on these meetings when you give a thumbs up,
Yeah,
it gives a big thumbs up on the screen. But also practical versus fundamental. It's a really interesting thing. So when I was studying metallized explosives, we were tremendously well funded. They would do large scale tests, which costs tens of thousands of dollars on the low end to find out the fundamentals of what's happening at a very, fundamental scale. Like we would want to know an answer within 5%, 10% of what an impulse load would be or an impact of a variable. For things to go bang in milli and microseconds, that's pretty precise. Then when we move to industrial safety, the funding is less, the ROI is less. There's also a real push to practical.
yes.
Okay, how do we get an engineering curve here? How do we get the data and draw a line through the data? And we're kind of okay in industrial safety, plus or minus 50%. Like it's like, looks all right to me, or even and it was really quite jarring to me coming from that background of okay, let's dive and figure out what's happening here and build the model up to industrial research, which is less funded in a way. And when there is funding, it's very practical. Okay, what's the engineering curve we can get out of this? I think in combustible dust, we've suffered a bit.
We have
tying the fundamental science all the way through to the end. There's some advantages there too. We've created test methodologies that work reasonably well on large scale, that are cheap, relatively speaking, and easy to assess and implement. But then when they go wrong, if you can't tell why that aluminum, micro or nano aluminum particle burns way hotter than we think this engineering curve fits, or has a lot larger pressure load, that's because we don't understand the fundamentals. And we could get into some of that if you wanted, but there's all kinds of fun stuff that happens with different particle types. Anyway, yeah, it's I'll let it. Why did you ask about that? Because I've never been asked that question on a podcast.
Because it's one of the challenges that faces within the industry, like if we look at end use applications, so we're looking at like large scale operations. Dust safety is seen as a secondary requirement, and typically in Australia and New Zealand, it gets pushed from an insurer or risk assessor. So an insurer or risk assessor's flagged that there's a combustible dust, and then it's a case of going, okay, well, how are you managing that? And so what I've experienced within my career is when people come from either a heavily funded position into industry, it's like there's that jarring going, well, we know that this is a significant risk. We're trying to implement all of this mountain of knowledge that we have. The company wants access to that knowledge, but then there's kind of a disconnect going, well, you need to fund it to be able to get it, because even though we have this wealth of knowledge, how you're operating your business, the materials that you're using, a subset that we haven't accounted for. So for us to be able to account for that, it's going to cost X amount of money. And then there's the discussion around, well, we don't have that money, we don't have that funding, what's the return on investment? Where can we see the efficiency gap within it? And then it comes a discussion when you see operators come into the equation, or corporate engineering or like corporate engineering management teams. There's always well, I thought this was done. I thought we had this. I thought we had this safeguard. Aren't we compliant with this? And so that's what we see a gap in the market, is bringing all of those things together and going, well, yes, you are right, but you're not seeing the whole picture. You're only seeing a portion of it, because they're getting information from all of these different external sources, whether they're a consultant, risk assessors, underwriters, operators, current knowledge levels, whatever they are. But then they're seeing that through their lens, and they're seeing it through the lens that's applicable to their role, like delegated function, authority, capital spend, whatever that is. And so it's not showing the whole picture. So that's why I asked that question.
I love it. Yeah, no, we see the same thing. And the other piece that comes in with that whole picture piece. So it's like a on a picture, like if we could draw a map, and this is what I've been trying to do for 7 years now, with dust safety, we could draw a map of combustible dust, like what
Mm,
all the things are, all the problems, map with the whole
mm,
problem space. The problem is people have if you had like a magnifying glass and they just look at the thing that's relevant to them. And
mm,
what's relevant to them is just what blew up last week.
mm,
Um, so you got us over here in whatever in Canada,
mm,
wood dust, 2012, two explosions back to back in British Columbia,
mm,
um, forever impacted many, many, many lives out there.
mm.
And so that's what we think about. That's also what we think about in the UK right now with the Bosnia Mill explosion a few years ago.
Yeah.
Where in other countries, in Brazil last year, the big grain dust explosions are very heavy on grain.
Yes.
1987 over Christmas, no, 78. I think it was 78 over Christmas in the USA. There were 6 or 7 or 8 grain elevator explosions, took the
Mm,
lives of 80 workers. They
mm,
implemented a nationwide standard within 2 years.
mm.
Um, but it's just sort of whack-a-mole. And other
It
countries, like in
is.
Japan, it's much more metal. In Taiwan, it's much more plastic. And it's really just everybody's little magnifying glass only focuses on the thing that happened most recently to them.
Mm.
With dust safety science, that was the vision. It's like, well, we can expose the whole map. Your
Yes.
plant in Taiwan looks exactly like this plant in Canada that's processing plastic, and
Mm,
maybe we realize that, hey, it's just dumb luck that you didn't. If you're running the same way, you didn't have an incident last week, and they did.
mm.
It's just how risk works. That maybe we could enlighten some people. I think we made some strides there, but it's people forget as fast as they remember in safety across the board,
I
and
think that
it's part of
I,
it.
th- I think with that, like that's one of the challenges, and I think this is probably more to deal with human behavior. But there's a perception that I've seen. Um, there's a perception that if you pay for something, it takes the problem away. So, say for example, if someone's engaged a service like yours to review the site, to review all of the safety articles and to implement change. Once you've paid for that, that's it. But compliance and safety, from what I try and educate our clients and our potential clients and our audience, is that safety and compliance are two different activities. Compliance is ongoing. Compliance is the actions, the proactive actions that you're engaged with to ensure that the equipment that you have within your plant is maintained and will function correctly, and also the control mechanisms that you have are robust enough to ensure that are robust enough and are tested enough so that if something does go wrong, you can demonstrate compliance. Safety is the human element for it, the human interaction space for it, because you're providing mechanisms around how a human will interact with that, how a human will interact with other people, how a human will interact with machinery. They're two separate portions. You can have a safe work environment, but you might not be meeting your compliance requirements. It's that I see that challenge, broadly speaking, is a big um a big like area that people need to have like discussions about, because you'd see it as well. You'd see like I'm not bashing any company or anything like that, but you would see that there's company safety statements, and when you go inside, people are trying to do the best that they can do, but the information that they have is not allowing them to do the best thing they can do.
Yeah, and I mean, I don't know what the name of this one is, but there's all these human psychology things that come in. So we paid for it, so now it's safe. That's like a
Mm.
version of kind of like a sunk cost fallacy.
Yeah.
There's just normalization of risk, which is normal behavior. To give you an example, we both know of. If you see a toy on the top of your stairs, you're a safety guy. be like, I got to pick that toy up. There's my kids, my kid's race car or whatever. We both have young kids, so
Mm.
and so and I do that. I'd be the same way. But then if I forget, the next time I see like, oh, I gotta pick that toy up. If I don't pick it up the second time, it's there 2 weeks. I don't even see it anymore. That's
Yeah.
normalization of risk. And I look at it and go, how is that toy still there? Like it's been it's been 2 weeks and I haven't moved it. And that's just because no loss has occurred from that toy being there. So
Yes.
now my brain's blocked it out. Same as probably to try to protect me from tigers or protect me from faces that are looking tigers when I like there's some human element there. And that's what happens, right? Because even in the worst thing, I'm sure you've seen sites that are just that you look at it and go, how is that not? And even under the worst conditions,
Mm.
it's infrequent. Now it can be frequent enough to drastically impact the bottom line. Certainly be frequent enough to take lives. But on a watching the clock happen, it's just generally infrequent, even under pretty bad conditions. And you know this if you're a person like me that tries to blow stuff up sometimes, like go try to create it. Don't do this. Don't go try to create it. But if you're from the testing world and you try to actually ignite a dust cloud, throw it up in the air, you can get good at it eventually. But
Yeah.
it's actually kind of challenging to get conditions perfect, even when you're trying. So my point is that natural then of that toy on the stairs is just going to keep happening. You're always gonna. It's like a chess clock. As soon as an incident happens, it's holy smokes, we got to do something. We got to investigate. We got to understand what happened, and the clock just starts ticking. And 24 hours later, 48 hours, 2 weeks, 1 year, you're going to normalize that risk as nothing bad has happened, and until operation conditions get out of whack. And that's kind of where you're at with the compliance safety pieces. The other thing happens is things always deteriorate to chaos. Entropy always occurs, and so your controls get weaker. Your secondary controls, your layers of protection erode. Your people get overworked. They have hard seasons and easy seasons, and once those kind of cross between that normalization and risk, there's a part there where you end up being in unsafe operating conditions. But it's like normal. It's not necessarily like people aren't bad people. They just like literally. I've heard stories. Yeah, I won't say the country or anything, but like, where a consultant will go in and talk to the owner of a small business and say, have you ever had an explosion here? Where you have any problems with combustible? No, like, no. Like, what do you mean? Like, no. And literally walk down the hall to the plant, to the operating room, and talk to the plant manager and go and look at and plant manager burns all up and down his arms. And it's like, what's the deal with the burn? It's like, oh, we had a dust explosion 2 years ago and burned up in it. And you're thinking, and it's like, but the owner knew that he was going to go down and talk to the plant manager. The owner wasn't like lying because he was trying to be like, he was bringing him and his consultant to talk to. He knew the next thing he was going to do is go talk to the floor. The owner it's just not like natural human condition. Nothing had happened for 2 years. He totally forgot that this guy was maimed for the rest of his life, for lack of a more gentle way to say it.
Yeah. He's like, and he's probably like, a bit laissez-faire about it. Oh yeah, like, we had that happen XYZ times. Yeah.
Well, it'd be like a rite of passage in Australia or something. We're a little more gentle in Canada. It'd be a very serious thing, but
we're not that bad, like.
Yeah.
It's really, I think complacency. There's two other opposing forces with it. So you've got what you touched on with complacency. So like, that just breeds, oh, well, we haven't had an incident. So like, it's not going to happen. We're doing the best that we can. And that does play one part of it. And then it's also like, if you look at it from like a standard risk matrix profile, your frequency and is infrequent, but the catastrophic, like the severity of it is always catastrophic. It always is. So that's what people kind of weigh up from a HASP perspective. But I think another disservice that some players within the industry, when they're they're saying, they're being consultants around combustible dust safety compliance. It's a selling point on fear, and I don't think that does the industry service. I really don't. It's if you're going, oh, well, you haven't had an explosion now, but you're going to have one because you're doing this, you muppet, what do you think? What are you doing this for? I think there can be better forms of opening discussions and having mature conversations and being a source of information. Whether they choose to listen or whether they don't, that's their decision. But I think personally that's an area which the whole industry can improve on.
I would agree. It's my favorite topic. And so I don't have this theory worked out, but I'm trying to work on it. How do I say it? So it's lazy selling is what it comes down to. People don't want to put in the effort to, like, it's just taking the easy way out to say,
yeah, it is.
Well, you haven't had an incident yet, so one, it's not even probabilistically true. Probability doesn't have any memory, so you're no more likely than. But if you're operating unsafely, then you have some certain level of probability. But just because nothing's happened yet doesn't mean it's going to happen automatically. It's not how it works. But that's easy if you're a dust collection person or exposure protection person or even a safety person to fall back on that. I think there's much better systems to sell safety out there. Maybe not out there, but we're trying to figure out how to define it so you're actually getting a return on your safety investment. One of the key things is actually to talk about it. And I'll give you a really good tip. Somebody gave me out of British Columbia, actually, health and safety manager. So I'd fought for years, tried to get investment in safety, couldn't do it. So I just went on my own, just tracked. What I found was that every time we had an incident, things like shutdown and employee like lost time production and everything, it just went into OpEx, and nobody tracked it. So I kept a spreadsheet and tracked it for 2 years and said, let's pull this out of operating. Let's see what our actual cost of this 2-hour cleanup is. This actual cost of this day-long shutdown is actual cost of an employee being up. And by the end of the 2 years, it was 5 figures, 6 figures of loss from those events. And so his argument then was, well, we invest $20,000 for a hazard assessment and $30,000 for equipment. You have $200,000 on the table you can get back from that investment and actually get a return on your safety investment. But it requires the business intelligence, the insights to actually pull those numbers out. And that's the part that we often don't have, I find. So I'm coming with a theory on how to sell safety better. I don't know what all the solutions are, but something around, let's not just say, hey, you're gonna get injured or die or hurt your people or whatever. Like we gotta come up with some stronger arguments. And I think there actually is an argument to be made on return on, like, not even there's argument made on like the fluffy stuff a bit, like return on productivity and return on employee morale and return. That's all real stuff too. I shouldn't say fluffy. That's downplaying actually how important that is. But I think there's like hard. I think if you looked at most of these businesses out there, there's actually like hard dollar value loss that's happening because of these and just not being accounted for in a way that can have to be a denominator. Which one goes on the bottom? Whatever one goes on the bottom in return.
On the bottom line.
I have several advanced degrees in mathematics, by the way. I can't remember where the denominator or the numerator goes on the bottom, but
denominator is bottom.
There you go. So I don't know. I'm not sure if you have anything to add there on.
Yeah, I do. Let's go down this rabbit hole, because this is a really interesting rabbit hole. So because it also touches on compliance as well and safety. So when ROI is a discussion around safety, it can be very hard to materialize it unless you're having that discussion. And you're exactly right. There's loss prevention, so LP costs that go into it. There's the human element, so that's ROI as well. And then there's also production costs on top of that as well. So you've got all of those factors, and because you're right, like some of them go into a capex, but some of them come off capex because it's associated with the production line. Some of them are factored in or absorbed through OPEX because it's more seen as an operational cost, and some of them aren't even accounted for. If we like to start out just looking at what they have currently and what they're doing and what the driving mechanism for it as well, because another big factor that we find is underwriter costs are becoming more and more apparent, because there's discussions from underwriters and they're going, well, this place isn't insured, or it's not insured correctly, or it hasn't been assessed. And so risk assessors are coming into the space and they're seeing it from a particular lens as well. So, for example, when we talk about classification of hazardous areas, one of the big portions I've seen here within Australia and New Zealand, when I was a regulator, the classifications weren't being done correctly, because a big portion of it is having what's called a dust containment study. In Canada, do you follow NFPA or do you follow 60,079 for your?
No,
No,
no, it's closer to NFPA though.
it's closer to
It's
NFPA.
closer to NFPA, yeah, and it's a mixed bag. We adopt the International Fire Code, and
Yeah,
each province kind of tailors things a bit differently depending on what they've adopted there. It would not it would be pretty common to see NFPA guidelines applied for most
yeah,
sites in Canada, and then some sort of kind of like
homologation.
electrical stuff on top from more international codes.
Yeah. So we don't have a standard in Australia and New Zealand for like dust hazard analysis. So we fall back to NFPA for that. But that deals with more like the fire protection elements of the production lines. The electrical equipment and the mechanical equipment selection fall under the 60,079 series, and the classification of dust areas is 10.2. But a portion of that, the person that's doing the classification is supposed to do what's called a dust containment study, and 95% of installations don't have that. And that's probably your biggest win, because you're to do that containment study correctly, you are to observe the production line and the process equipment under startup, shutdown, normal operation, abnormal operation, and critical failure. So you're looking at it and you're going, okay, how does it? Because you're wanting to see how that particular piece of equipment will interact with the material, how the dust clouds are formed, if there's any dust layers associated with it, and then on the back end of it, you're going, well, is this actual piece of kit maintained correctly? Because you've got like a ruptured sock that's blowing out like 10 kilos of product out the side of it per hour. Like, come on, let's like look at that. So if consultants were able to articulate what requirements were and follow what the requirements are, and also adopt first principles, you would get those low-hanging fruit wins to begin with, from a cost perspective, not worrying about the human element, not worrying about morale, psychology, the feeling of feeling valued and safe as an individual. So you've got those factors, but there's so many variables that you can put into what is safety for a company, how that's implemented, what does it mean to feel safe for a department within that company, how does it feel safe, what does safety mean for the individual. And so I think those discussions are much more meaningful than you're going to blow the place up and you're going to have another Lebanon, you're going to have another Beirut. So what are your thoughts on that?
I like this dust containment study thing. That sounds really good.
Yeah.
I don't know if I've ever heard that specific terminology. I just Googled it to see if I could come up with anything on it, and Google also hasn't heard of it. So that's it's a really nice way to look at it. I mean, what we might hear in North America, they might say, well, some of the old hat guys, dust, contain, collect, clean. So we want to contain in the pipes. We want to make sure the dust stays in the equipment. Anything we can't contain, we want to be able to collect at transfer points. And then anything that can't be contained or collected, we want to clean it up with vacuum systems or safe cleaning methods.
Mm.
And that's the closest I've ever heard of a dust containment study, but I like it. The framework we're trying to create like a meta framework that fits everybody's framework, and it's just simple. It's identify, assess, address. Identify, assess, address. Identify, assess, address. So if you're in North America, generally identify means testing and looking node by node at each piece of equipment to see if it has a fire, flash fire, explosion hazard. And so that's the identify, and then you assess each piece of equipment for its controls against that fire, flash fire, explosion hazard. Come up with a list of recommendations. That's your DHA process, and then you address the recommendations on some frequency or in some order. That's your implementation plan. In international, it's almost the same, but the identify always seems to be, at least in other countries, I haven't heard, like, again, this dust containment study is an interesting aspect to add. I'm not, although I've done 260 podcast episodes only on combustible dust with probably 80 countries around the world. I'm not fully well versed with everybody's approach, but identify in a lot of international is much more focused on a hazardous area classification. Kind of step one, and ignition source control through certified equipment. Generally, we put that under identify as well. And then you kind of move into the assessment and the addressing as well. I think it's interesting. Those two we'll call them choices. I don't know if they're choices, but those two choices start with testing and sort of a node-based view of things, or starting with a hazardous area classification, and looking at your ignition source control. I don't know why, but they seem like those two choices influence the entire assessment all the way to the end, and not in bad or good way. And you get a European saying, no, this is the way to do it, and you get an American saying, the cowboy hat on or something, saying, no, it looks like this. Like, both have strengths and weaknesses. The hazard area classification, the biggest strength, I like it because you can actually see what the heck's going on. It's kind of nice. But the biggest weakness is it's sometimes so borrowed for oil and gas, you won't even do it for dust because you don't even. I know there's a systematic approach to do it, but a lot of people will do it wrong or not know that a hack is even needed for a dust facility, where there's numerous problems with the North American method as well. And like I said, we're trying to fit into all, just identify, assess, address, and figure out the strengths and weaknesses are across for all of them.
So the biggest, we simplify it for our clientele because they ask the same thing. Why are we doing this? Why are we doing that? Hazardous area classification, the primary driver for that is the selection of equipment, whether it's mechanical or electrical. Dust hazard analysis, the purpose for that is to be able to identify where your dust hazards are, and then for a appropriately certified fire protection engineer to come in and look at either suppression systems or control methods if a fire does occur, to reduce or to mitigate the explosivity of that particular item. The two are different and have two different applications. Yes, there will be some crossover between them, but they are two different safety processes or safety input documents. So that's how we distinguish the two from each other. You can have learnings from one that feed into the other, particularly if you're having like suppression systems. You want to be making sure that your equipment marking is going to be suitable, and at the same time you want to be able to reduce equipment where required, because you just don't want to have that control or that safety complexity layer on top of it. Yeah, I can show you the wording of the dust containment study if you want. I can share my screen and read it out. Do you want to go? All right.
So this is This is within the Australian standard, and do you know if it was adopted from somewhere else?
No. It's not the Australia. It's IEC standard. So
okay.
I'll have to.
IEC. Okay. Well, then I'm showing my lack of coverage of the IEC standard. Then I guess.
Yeah, I can't share it on this platform, but I'll read it out and I'll send you a snippet with it anyway.
You make it a legal notice from IECEX.
No, you're allowed. No, you're allowed to share. Like, you're allowed to share it and you're allowed to put it in context. But going back to more regulator dates, but it has to be in italics, and it has to be like, if you are referencing it, you have to reference
That's
the
that full
complete
citation. Yeah.
full citation of what the standard is. So within 60,079 10.2, section 5.2, dust containment says, inside the dust containment, dust is not released into the outside atmosphere, but as part of the process, continuous dust clouds may form inside the containment. These clouds may exist continuously or may be expected to continue for long periods or for short periods. The frequency of their appearance depends on the process cycle. The equipment shall, so shall is a mandatory requirement within Australia, so we define shall as a mandatory, we define should as a recommendation, and that's in legislation. So the equipment shall, mandatory, be studied for normal operation, abnormal operation, and in the startup and shutdown conditions, so that the incidence of cloud and layer persistence can be identified, and the results of this study shall be included in the verification dossier. Where layers are formed, these should be noted. So your dust containment study goes back and goes, okay, where's your process equipment? Let's look at it in startup, and normal, abnormal startup shutdown, and then let's make that report. And then how does the piece of equipment contain that dust? And if it does, what are your zones going to be around that? So that's kind of an input requirement for classification. So I'll give a snippet of this, and I'll send it to you as well, so that you've got it for future reference. But that's what is a requirement for classification, and we find that is one of the big missing points, because if that was done correctly, your loss preventative measures, your housekeeping measures, your containment, your cleanup would be more robust, because you'd be viewing those things, you'd be going, okay, we're going to bring a new piece of kit in, or we want to do this reassessment, we're going to look at it every 3 years. It's going to be part of our routine activities, because, that's a compliance requirement. But how it's implemented in the business is different, and who's doing it and how they're doing it is different as well.
Yeah, no, it sounds fantastic, and we're actually we're running a Combustible training program, a little more North American focused, but coming out September 17th, so 3 weeks at recording, and I'm not sure when it's coming out. It may have already happened. But the reason I bring that up is I'm talking to a lot of people right now, and when we say a lot, I've had 300, 400 conversations in the last few weeks on what's your challenge what challenges do you have in educating yourself in combustible dust, your team, your employees, your clients, and I'd say probably over a dozen conversations have said, hey, I really just don't understand hazardous area classification for dust. And I think what they're trying to find, these individuals, is they actually want to know, okay, if I have equipment A, how big's the circle? But what you're suggesting with this dust containment study is that's how you evaluate that's the input to your hazardous area classification. That those people that are asking me for a course on hazardous area classification, which is not the top, that we're doing much more fire, flash, fire, explosion on node-based approach. Testing, here's your controls, how you evaluate which controls to use, how do you work with a DHA provider to come with your rotation plan. These are all things that are covered in the training that we're working on, not as much on hazardous area classification. But to me, that's the answer to educating us. You need to do a proper assessment of your system to understand where those clouds are being generated, the duration of those clouds. I love the fact that you're including startup and shutdown, critical operation. You wouldn't be amazed, but people would be amazed. Like when the power shuts off,
what happens?
And the pipe's like this. If we're on video, the pipe's on this deep end. All the material comes down the pipe. And guess what happens? Guess what the most likely time to have a fire is on your site? When you have a power, because of the power shutdown. So these are good things to think about. Those what's going to happen when we have slam shuts. All these unnormal conditions are the most likely ones to have an incident.
That's exactly right. Like, a lot of people ask us what we classify as abnormal, and what we the example that we give, you would have seen debaggers like in your debags are a perfect example of that normal operation. Those bags get stuck. Debag is always the bag. When it's splitting the bag, it sucks the bag up, the bag gets sucked, and you get this massive plume of dust that just comes out. So, like, guys, you need to factor that in. You need to factor that into your classification. We're not saying that it's normal, but there is a possibility and it is frequent. And you do have a, standard operation procedure of what happens when the bag gets stuck. So we need to account for that with our classification. But touching on one of the sections that you pointed on when people come to you and ask about classification, what we find is people want the standards to provide them with a prescriptive measure. They want, you have this, therefore this is the zone. And that's not how standards are written. Standards are written in order for professionals to interpret it, to get guidance from it, and to go back to first principles and go back to their client and go, well, how you operate, like the standards are not written for every single client individually. The standards are written and adopted for an industry because an industry has certain requirements, and there's certain performance requirements of how they're to interact with it. A committee team can't sit there and work out every single nuanced parameter for the industry. That's what the engineering consultancy community is supposed to do. Like, go to their client, understand their process, map it out, view things, or like provide like computation against it. There's some great software systems out there that can do some very, very granular computations to show the effects of dust clouds within process equipment. So utilize those as a basis.
Yeah, I spent a decade writing that software. So I do not write software anymore. I gave that up when I finished my last academic degree, my PhD. I said I'm not writing code anymore. So I gave up my Linux box over there, and I don't do that anymore.
You got sick of looking.
Yeah, well, non-reactive multi-phase flows are hard enough. Trying to get reactive multi-phase flows to work and be sensible is enough to drive somebody crazy over a decade. So, I did. It's all in my. It's all.
I'm sorry for bringing that up. I'm sorry for you having to relive that painful memory.
It took me 8 or 9 years to finish my PhD degree, and I remember about year 6, I got my first dust explosion, like dust deflagration. Very easy to simulate dust detonation, and there's all kinds of mathematical reasons why that's easy. It's elliptical and hyperbolic, or there's reasons why. To do a deflagration, something that happens at industry scale, it ends up being really difficult. And I remember I ran upstairs and had this 1D simulation of a coal dust explosion, and it was proper. Like, it was what the velocity of the flame should be for that material. And I had my laptop and I like ran upstairs, showed Kelly, like, Kelly, look at this. It's just like a dumb line that goes across the screen. It's like, it's a dust explosion. It really is. It took me 6 years to get to this point. Now there is some software that can do it a bit better, that can be used as actual tools to get more sensible assessments and stuff. And there was some tools back then too. They couldn't do it at a precision level that would allow the type of research that I was doing. So I had something that simulated a precise dust flame. But anyway,
even with that though, there's all like getting the like modeling for the deflagration's one thing, but then when you look at positioning that on, or overlaying that on a like process plant and how that will interact, like that's in magnitude levels. Like, you're talking about the complexity and the computational data set that's required to get that to interact correctly. Like, that's huge. And you
there's
see
a couple groups. I mean, Gexcon, Flax, DustX
yes.
has a code that works quite well. ANSYS has a code that works well at it. I used OpenFOAM. Don't do it unless you really want to not be happy with yourself. And there's also actually an Australian team, Advanced Analysis,
Mm.
that has a good code as well. But it takes a special type of consulting company
Mm.
uh, to take those sort of projects on, because
Mm.
you can't, like, if I use Flax as an example, it's pretty easy to use. You
Mm.
you you run a 20-liter test, you get a curve, you stick the curve in, you import your geometry, and it's then they've spent a lot of time in making a really good geometry importer. So
Mm.
you import hey, there's your mesh. It's great. You can run a simulation and you got an answer.
Mm.
Um, a master student knows what they're doing, can do it on a weekend.
Mm.
But the longer period should be the weeks of criticizing by a knowledge person to say, is this answer, do we believe it? Is it
Mm.
sensible? What parameters affect it?
Mm.
And that level of engagement takes, folks like yourself or others. We're just not quite there yet as a community to use it all the time, but
No.
for hard challenges, pressure piling is a really good one.
Mm.
Isolation, those are all challenges. Fireball
Mm.
size and shape,
Mm.
loads on like, are we gonna blow this manager's window? Is this vent panel gonna blow the windows of the side of the adjacent building? All that sort of stuff that can be really done with CFD pretty good today.
Mm.
I shouldn't actually not. It's a really good tool as well. It's just I don't know. There's
It,
maybe 50 people in the world that are really using it in having it. Maybe I'm off on that number as well. I don't know. Like I said,
no,
I don't
no,
write code anymore, so I don't even want to touch it.
it's what you're saying. What you're saying is true. It's more to do with like what are the benefits of the application going into that granularity.
That's a good
Like
point.
it's what if you're if you're looking to model something, like why are you looking to model it when you could just put in a risk factor or just put another conservative 10-15% on your results and go, let's use this particular piece of equipment or this methodology or this barrier from a practical standpoint rather than going down the cost of modeling, because that's how industry sees it. Yes, it is a good tool, and it's typically used for abnormal cases, and it's typically used for, like, what we've seen it used for is high value material simulation. So when the lactoferrin was a big one, so lactoferrin mills, modeling those mills in order to reduce their loss was one of the cost benefit analysis that was needed to provide to the client, because you're looking at $5,000 a kilo for lactoferrin at that quality grade. So like if they're losing 100 grams, how can we prevent that? So if they're losing 100 grams an hour, well, that over time you're losing like $20,000, $30,000 a run. So
Yeah,
I
we've had requests through Dust State Professionals for CFD, and they've generally been, trying to think of, like highly congested areas, so a lot
mm,
of bucket elevator lags in between
mm,
buildings and stuff where it's hard to say, hey, should we go flameless venting or should we do traditional venting?
mm,
Kind of
mm,
those sort of assessments. Fireball diameter, shapes and sizes, and whether or not they're going to cause radiation loads on adjacent buildings or populated areas, that sort of stuff.
mm,
Pressures on buildings. Another one comes up, isolation is something we've seen. The answer is almost always, if you don't isolate the explosion, it's going to be massive after a couple hundred feet of ducting. But you can simulate it and then show that that's the case. You can
yeah,
actually, I guess, you can actually potentially use the size of the other vessel too, if you're gonna allow it to be unisolated or you can't strengthen the ducting.
mm,
We've seen these kind of feed mills and stuff
mm.
where there's too much crappy ducting that's not strong enough to hold explosion anyway, so you can't put an isolation valve on it because it can't hold
Or
the
just
valve. So yeah, how bad is it going to be at the end?
mm,
Might be kind of a use case for that. So I don't know. There's definitely some different areas that are. I think combining it with the the particle movement, like you're suggesting, is actually an area that might be really fruitful. Like to understand what is the actual cloud in, I don't know, like a belt dryer system. Are we even
Mm.
generating clouds in there that
Mm.
are, and how can we have that flow of material inside those process equipment to actually reduce the amount of
Mm.
cloud generation points that are in there? And instead of just waiting until it goes bang and then be like, oh yeah, I guess there was a cloud in that thing.
Yeah, it's all about that preliminary simulation. We find like that's probably the best use after the thing's built. Like, what's a model going to provide?
Yeah.
Model's not going to provide any kind of like return or any additional like you can physically now see the device in operation, and you can probably adjust pressure. You can adjust flow rates manually on things anyway to reduce things if you need to. But then again, you've got to make sure that you're getting the product that you want at the end of it as well. So yeah, I think
The other
there's
case that I'll mention too is increased pressures and temperatures too. We don't really have a method to test increase and decrease. If you're
mm,
running a process in a fridge, it turns out dust explodes in a fridge.
mm,
Somebody asked us, and we actually found two cases of explosions in freezers.
mhm.
We could not convince North American Test Lab to move their 20-liter chamber into a freezer and do some tests for that client. But those are cases where you could use simulations to see what the impact could be of an explosion under these sort of different conditions.
I think that that's like a really intriguing topic though, because that also talks into the level of um awareness, because you would have like that when you're talking about combustible dust, a lot of people go, oh, well, I've got a safety data sheet that says that it's not explosive. And so, like, yeah, we're talking about two different things here. We're not talking, the dust isn't going to, well, unless,
Not the
unless,
product necessarily, although it could be
it's-
the product too.
unless it's coal dust, like, and it
Yeah.
probably is going to exert methane, like, as far as a vapor, but the dust isn't going to provide that vapor that's going to be ignitable. We're looking at the combustibility of the dust, so it can happen under like under refrigerated temperatures and under freezing temperatures, because that's not a factor in its profile for explosivity. So
Yeah,
yeah,
somebody, yeah, like could it be in a refrigerator? It's like, well, the world has stopped at 20 degrees Celsius. Like, why at 16 or 14 or even zero would it? And it turns out we had, yeah, I know of one case of a large industrial freezer, and then one case of a home freezer. Actually, it was a local investigator reached out. It's like, hey, this freezer blew up. Can you take a look at these pictures? And it was like a bag of almost talcum powder inside the refrigerator, just dumped, and static. The fridge wasn't grounded,
mm.
and so it created a cloud in the fridge, and the door blew
Static
up the fridge,
discharge.
and you can imagine the fire investigator showed up and like, how, what's, is this a meth lab? Like what? But it's like, there's nothing in this fridge. There's just this little bag of white powder.
Why is there a flame language here? Like what's going on here?
Yeah, it was quite they couldn't figure it out. And anyway, this was like, I don't know, 6 years ago or 5 years ago. They sent it into our help desk, and but they showed me the pictures. It was fun.
That would have been impressive to see. Like, it would have been. It would have been if you're dealing with fire, like the fire protection or like fire first responders. They have a wealth of knowledge. They do. Like,
Yeah.
as far as fire languages, fire models, they're fantastic, and I find that they're always eager to increase their knowledge. They're always eager to like go, well, we don't know everything. We're still learning. They're in this continuous learning cycle, which is fantastic to see. So yeah, excellent work on that one.
Yeah, it was a good one. We get all kinds of fun and not so fun stories, I guess, for dust explosions. But it comes to the point that I try to say before, like this magnifying glass thing. Like it really is a case of just what happened, and I'm not knocking anybody at all, but like, so we at our annual conference, we typically have, like Occupational Health Safety Administration in the US or NFPA or Canadian people and
Mm,
lots of European standard development organizations keynote these things. And
mm,
so we asked, I think it was last year, like, OSHA came out with in the US, came out with a revamp of their national emphasis program on combustible dust. And they release in there, here's a list of the industries that we're going to focus on this year or in this NEP, so probably for the next 3 or 4 years, for combustible dust, not investigations, but whatever the word, we'll call it an investigation. When they come in and look at a site to assess it, we'll say assessment.
Just
I can't think of what they word. Like this kind of, because a quizzical guy on the podcast or on the webinar is like, how did you choose those industries? It's like, oh, those are just the ones that we've had the most explosions in the last 4 or 5 years or the last 10 years. Like shouldn't we look at the whole world to see where else it's like, wow. And so I'm not knocking the US. I'm just using that as an example. That's exactly the mentality. It's like what blew up in, how does this impact me? It's like, just because you haven't had a 3D, and we've had a number of 3D printing explosions in the US, but in North America, but like we need to broaden our scope a little bit more. It's not just what's happening in your back area. It's too infrequent. If you ask people in Zimbabwe, they did a whole audit of all their grain elevators in Zimbabwe because they had a large grain elevator explosion in 2018. Same as in country of Jordan, Port Aqaba. We had Ali El Nashdawi, who was the lead investigator for the Port Aqaba explosion. I think he's our 3rd podcast episode 6 years ago, 260 podcast episodes ago, talking about that grain elevator explosion and how it impacted not the regulation in the country of Jordan, but that government went to every grain silo and audited all their silos. But it's just whack-a-mole.
It is.
We need to look at it with a broader lens of what is the possible risk profiles across all industries, not just what happened to us yesterday. Because you always imperial sugar wouldn't have been identified as a risk until it happened, and then we went nuts on sugar. There's still sugar factory explosions around the world. There's at least 1 or 2 major ones that blow up every year. And if I just convince those countries to, hey, sugar dust is explosible, I'll give you a fun fact. The first regulation for combustible sugar dust was written in the U.S. The first U.S. regulation was written in 1922. It said, it's not verbatim, but I'm quoting. I'll pull it. It said,
paraphrasing.
Put the dust collectors in a separate building, away from workers, monitor the bearings to make sure they don't get too hot, and vent any equipment that can have an explosion. It's like all the things that would have fixed imperial sugar were written 100 years ago.
Yeah.
So there's the information's out there. It's just that they don't have it frequent enough for us to remember it, and then we forget, and then we deteriorate into more and more risky conditions until something happens.
It gets back to that, it will never happen to me. It's just ignorance, kind of. Ignorance is lack of a better word, but it's just that it will never happen to me. It happened to them because they didn't do that. We do it better. And it's like, guys, we're not comparing you against them. We're not looking at it from a comparison perspective. We've said this is like when we talk about standards, like standard is the best practice. Standard is minimum. If you meet the standard, you have created a minimum benchmark. Like that's what we want for the whole industry. And if we're not all there, then it doesn't matter what that person's doing. It matters what you're doing. And if someone comes knocking, how are you going to have a how are you going to, because you can't go, oh, well, like I didn't know about it. Everyone has an obligation now. It's not, you have an obligation coming to work. There's duty of care. There's all of these legal terms that don't safeguard people. Like pleading ignorance isn't going to stand up anymore in this day and age, especially when information's out there.
Yeah, a helpful frame to think about it for companies I've seen employed by some of the largest companies in the world on combustible is it's like to write your own internal document, your own standard. So the compliance standards are the minimum set, and so you could adopt them, but my guess is they're too complicated to somebody to read at your site and be like, what does this mean? So just write out this is how we do it here. And ideally you make it meet the minimum requirements. You don't write, hey, we but maybe you do have something in there that says, we don't do, I don't know, we choose suppression over venting, or we choose venting over suppression because
Mm.
of X, Y, and Z. Like, just documenting that out, I think, is a really good exercise. And when I talk with, like, we'll say top 5 food producers in the world, that's how they're thinking about it.
Mm.
They're writing their own, and they have to, because they have to meet minimum standards in multiple countries.
Yes.
So they write their own company standard that
Mm-hmm.
is that meets or exceeds those standards
Yes.
across all the countries. If they're good, it's like,
Mm.
if they're forward thinking and
Mm.
doing it ahead of time. That's just a really nice way to think about it, is coming up with your own set of standards on how to do this, because you include other stuff in there, like, this is how we select consultants,
Mm.
the minimum set of requirements that we require for consultants. This is how we select vendors. And I know companies have different pieces of all these things, but tying it
Mm.
back into your safety standards, your own internal documentation on that,
Mm.
um, it gives you some way to train new teammates. It gives you some way to just to think and wrap your brain around this, rather than every time you need to understand something going into NFPA 652 and going, oh, where is that in this 300-page document again?
Yeah. Or not so much not so much being able to crawl through the standard, but it also, if a company's writing their own standard, you can get nuanced about the implementation of a particular clause or a particular set or a particular like chapter within a standard. This is the this is the like regulatory act, or this is the requirements, or this is mandatory standard. This is how we're going to implement that within our business as well. Or this is how we're going to, as you said, deviate from it. And these are the reasons for it. So I'll fully recommend and agree with that
Yeah, and a
sentiment.
regular comes knocking, like, they're going to appreciate that
Yeah.
so much more. And the biggest complaint to that's going to be like, what if we get sued? And then it comes discovery. And trust me, I've been on the other, like, I've been involved in some of these cases, and sticking your head in the sand isn't, it doesn't work all that well either. So
No.
it's just a more proactive way to go about it.
But from an Australian's perspective, when I was in the office of DOJ, we would rather see proactive. We would prefer, we knew that no one was hitting the targets, because things change, targets change, standards change, there's all of that balance. So it's all about balancing it out and going, well, what would a reasonable person have done? And then seeing proactiveness and seeing a semblance of some form of implementation was better than sticking your head in the sand. And you'd just be like, guys, I know you missed the mark. You did your best. Change these things, and then let's see how we can change things and make things better. You've done, yeah, this isn't an incident that we wanted to see, but it is what it is.
Yeah, it makes a lot of sense.
So we're going to wrap it up. So once again, Chris, thank you so much for your time and your wisdom and what you're doing for the industry. I think it's very honourable what you're doing, and seeing the impact that you're having and the change that you're wanting to drive. I thank you and commend you for that. It's really inspiring to see. So where can people find you? And do you have any last message for any of our audience?
Yeah, I mean, the if you're listening to this, my guess is you like to listen to stuff. So Dust Safety Science Podcast is probably the best place. It's beyond iTunes and Apple and all those sort of things. It's an audio only podcast. So if you're watching the video of this, you'll have to go on one of those platforms to grab it. Dust Safety Science is sort of the hub. The best thing is to go follow me on, or connect with me on LinkedIn. We're quite active there. And as Travis mentioned, Dust Safety Professionals is a connection platform if you're looking for help in this area. We try to do awareness, knowledge, connection, and change. So once you're aware of the hazards, you need to understand. That's the knowledge, the training, the education. And then a lot of time people get stuck. They're like, well, okay, who do I connect with in Algeria? Who do I connect with in Australia or New Zealand? And that's why we appreciate, your team and involvement in that. It gives people to go to once they say, oh yeah, we do need a problem, or we do need a solution to our problem. Then that's where that platform comes in. So
We'll
Best
put a
place
link.
probably the podcast, and then Dust Safety Science via next from there.
We'll put a link to everything at the bottom of this anyway. So like, just click on that link, guys. Like, reach out, connect with Chris. His team's doing an amazing job. And yeah, as I said, thank you again for everything, and thanks for taking the time out of your day on the other side of the world to come and have a chat.
Thanks. It's always fun to talk with my colleagues over in Australia and trying to find a time where we both align. I appreciate appreciate the time.
No worries. Thanks, and I'll talk to you soon.
See you now.
Bye.